So 5.2, 5.3, graphs of rational functions. Okay. To sketch a graph of rational function, so you can use x-intercepts, y-intercept, asymptotes, and if necessary, positive and negative intervals. Okay, positive and negative intervals, how do we get it? You already know it from solving the rational inequalities or solving polynomial equations. You know that you have to do a factor table to get the positive and negative intervals. So for rational functions, we're going to do the same thing for more complex graphs. Sometimes you don't have to do. For some graphs, you kind of need to do it. Okay. So what's the first of all rational function, right? So for rational function you have a polynomial divided by a polynomial. Let's if let's say numerator is called p of x and then denominator is called q of x. So we are looking at the wholes now. Okay. So this function will have a whole at x equals a if p of a is 0 and q of a is 0, so that you get 0 over 0. So at that point at x equals a, then you will have a whole. This is what it means. Then you have a factor. So if p of a is 0, it means that x minus a is a factor of p of a, p of x, and if q of a is 0, then x minus a is a factor for q of x. Okay, so means you have the same factor in numerator and denominator, so then you have a whole. Okay, so let's look at the example. Hopefully it will make more sense. You have f of x equals x squared minus 1 over x minus 1. So you factor this. So I think give me a second, please. Okay. So now after you factor this, what do you see? Numerator has a factor of x minus 1 and denominator has also a factor of x minus 1. So now this can go, but it will create a whole at x equals 1. Okay, x minus 1 is a common factor in the numerator and denominator. This results in a whole at x equals 1. So let's look at the examples for the wholes. Okay, so you have f of x equals x squared plus 2x minus 3 over x plus 3. So we will now factor the numerator. So what do we see? We see x plus 3 and x plus 3, right, in numerator and denominator. Then f of x will be this. So you kind of can simplify that. F of x is x minus 1, but with a whole at x equals 1. Okay. So this is not equal to f of x equals x minus 1. Okay. The difference is this one. If this f of x will have a whole at x equals 1. So because it has a whole, it's not considered a line, or it is not considered a linear function, but now it is considered a rational function. Okay, because it is coming from here. Alright, so let's sketch this to see what's going on. First we're going to sketch y equals x minus 1. So y-intercept is negative 1 and slope is 1. So you sketch y equals x minus 1. Okay. Now we are going to place the whole. When x is 1, we have a hole at x equals -3. Sorry, I was thinking what's going on. Okay, so we cancel this one, right? Therefore, actually, we have a hole at x equals -3. So whatever makes, so you look at that factor that you cancel, okay? So you look at the zeros of that. So -3. So we have a hole at -3. Sorry, when x is -3. So this is the hole. We fix that. Okay. So how do you find the y-coordinate of the hole? So you can already see it from the graph, but let's say if you did not have a graph, how would you find the y-coordinate of that hole? So you know that there's the x-coordinate of the hole is -3. So you can take that -3 and sub in the remaining function here. So -3, -1 gives you -4. So that is the y-coordinate of the hole here. A hole is not going to be given. So let's say you will get this. Okay. First step, you factor it. So you see that x plus 3 is a common factor. Okay. Then when you simplify, you get y equals x minus 1. But this one will have a hole at x equals -3. It's coming from this factor, right? Then to find the y-coordinate of that hole, so the x-coordinate of the hole is -3. What is the y-coordinate? You take -3, sub in here. So -3 minus 1 gives you -4. So the coordinates of the hole now, -3 and -4. So it's not going to be given to you, but that's how you can calculate it. Okay? So let's look at the next one. It is already factored for you. Now we see that x minus 3 and x minus 3 is common. Okay? So then f of x is x minus 2 times x plus 4 with a hole at x equals 3. Okay? Then we are going to sketch this x minus 2 times x plus 4. So you know that it is a parabola, right? X-intercepts are 2 and -4. -4 and 2. So how do you find the vertex? So let's remember that one. So you add the x-intercepts and divide by 2 to get the x-coordinate of the vertex. Okay? So 2 and -4, we add them. So let's say if the vertex is h and k, to get the h, so we add the x-intercepts, 2 plus -4, and divide by 2. So you are kind of taking the average of the x-intercepts, okay? And then you get -1. So to get y-coordinate of the vertex, you take that x-coordinate, sub in this function to get the y-coordinate, okay? So if you sub in, what do you get? -1, -2, -1 plus 4, -3 times +3, which is -9. So the vertex is -1 and -9. Okay. Then step pattern. So you see that a value is 1 here. Step pattern is 1, 3, 5. Okay. So you go 1 right, 1 up, 1 left, 1 up, 1 right, 3 up, 1, 2, 3. Okay. 1 left, 3 up, 1 right, 5 up, 1 left, 5 up, 1 right, so we said 1, 3, 5, 7, 7 up, and 1 left, 7 up. Okay. But again, we have to put the hole here, right? So we have a hole at x equals 3. So find 3. Okay, x equals 3. So now we know that there's a hole here. Even though it looks like a parabola, but this is called kind of rational function because it has a hole here. and that hole is created because, you know, the original function is like this, not directly like that. Okay, again, if you needed to find the y-coordinate of it, we kind of see it from the graph, right? Y-coordinate of the hole is positive 7, but, you know, if you wanted to do it algebraically, so we know that hole is at x equals 3, take that, sub in, you get 1 and 7, so you get also 7 from algebraic method too.